Hi there, my name is Anders Holm, and welcome to this portfolio video on audio repair and enhancement using iZotope RX7 standard. Please keep in mind that this is not meant to be a tutorial, it's only meant to be a showcasing of different audio related issues and how to handle them using RX7, and the technical know-how of using RX7 itself as a standalone program. Alright, so here we are inside iZotope RX7 standard. And the first example I want to delve into is that of plosives, because plosives is an extremely common issue in any sort of dialogue or singing recording because they can occur even when using proper microphone technique. So in front of us we have a recording that I've made with two pretty obnoxious plosives in them, so let's take a listen. Let's try and remove these plosives from this recording using the deplosive module in RX. Alright, so as you can hear, we have two very apparent plosives, and you can actually see them at these two transients. Maybe it'll be more visible if we remove the spectrogram. Here we go. Yeah, so right here and right here. And let's see if we can remove those two plosives. To the right, we have all of the modules in iZotope RX7 standard, and one of them is called deplosive. So let's click on it. Let's drag it out here. And so these are the default settings of the deplosive module. Now, again, this is not a tutorial. I'm not going to go through all of these settings and explain what they do. But I will say, though, that when doing any kind of audio repair or enhancement on an audio file, I almost always start out by just previewing the file with the default settings of any module just to see what kind of effect it does and then take it from there. So first of all, let's just listen to the original sound file again. Let's try and remove these plosives from this recording using the deplosive module in RX. Alright, now let's try and preview this audio file with the default settings of the deplosive module. Let's try and remove these plosives from this recording using the deplosive module in RX. Alright, so we've basically taken an audio file that was borderline unusable, and already it's much better. I would definitely say that this is a usable audio file now. Now, maybe I would go ahead and just take down the strength just a notch. I feel like the attenuation is a little much on the plosives. So maybe 3.8 is going to be a good spot. Now let's preview this. Let's try and remove these plosives from this recording using the deplosive module in RX. Alright, so I really like that. Let's take a listen to the original file again. Let's try and remove these plosives from this recording using the deplosive module in RX. And again with the deplosive module. Let's try and remove these plosives from this recording using the deplosive module in RX. Alright, and there you have it. That's how you can remove plosives with the deplosive module in iZotope RX. Alright, so let's move on to the problem of clipped audio. This is a recording that I made that clips several times throughout the duration of the audio file, and we can visibly see it by the cutoff waveform here and here, so on and so forth. But first of all, let's take a listen to this. This dialogue is recorded way too hot and therefore distorting. But let's see if we can fix that with the declipping module in RX. Alright, so as we can hear, there is noticeable distortion when the clipping occurs in this audio file. To mitigate that, let's come over here and grab the declip module. Alright, so there are a couple of settings here. The most important one being the threshold, because that is going to determine what part of the wave that RX is going to try and repair for us. As you can see, this is also visible in the audio region itself. Now you'll notice that there is a suggest button below this window. And if we press that, RX is going to suggest to us where this threshold should be set. Let's try and click on it. Now, in my experience, I always like to drag this threshold down 1 dB or 2 below what RX suggests. I've just found that that gives me the best results. Another thing I want to add is that you can also unlink these two sliders, the bottom and the top slider. Say if you have an audio file that has asymmetrical clipping in it, you can move these independently of each other. But let's link these back together like so. Over here, we can choose the quality of the processing from low to high. We can set the makeup gain, and we can have post limiting on. I think this should be pretty self-explanatory. But let's listen to the original audio file again. This dialogue is recorded way too hot and therefore distorting. But let's see if we can fix that with the declipping module in RX. Alright, now let's preview it with these declip settings. This dialogue is recorded way too hot and therefore distorting. But let's see if we can fix that with the declipping module in RX. Alright, so as we can hear, the distortion in the audio file has been noticeably reduced. And if we render this out, we can actually visibly see how RX has repaired the waveform itself. So let's go ahead and do that. And there we go. Here is our audio file if we close down the declip module. And here is our new, improved, repaired waveform. Let's give this a listen. This dialogue is recorded way too hot and therefore distorting. But let's see if we can fix that with the declipping module in RX. All right, and there you have it. That's how the declipping module works in RX7. One of the most common issues in audio is that of noise. Here I've made a recording in my bedroom with an air conditioning unit behind me. Let's take a listen. This recording has a really annoying air conditioning noise in the background. Let's see if we can somehow remove that. Alright, so as we can hear, there's this obnoxiously loud air conditioning sound, and we want to see if we can remove that, but at the same time preserve the main signal. And there are two different ways to go about this in RX7. There are two different denoising modules. One of them is called spectral denoise, and the other is called voice denoise. Spectral denoise is sort of the all-purpose denoiser in RX7. And voice denoise is a denoiser that is specifically made for removing noise from any sort of vocal or dialogue recording. So in this instance, I would probably go for voice denoise right away, but for the purposes of this video, let's start out with spectral denoise. Now, for the denoiser to work, RX needs a noise profile, and there are two different ways to find this profile. There's adaptive mode, whereas if we click this and run through the audio file itself, RX will try to automatically distinguish what is noise and what is main signal. But we can also do this manually. We can select a part of the audio file that is only noise, so for example here, and then we can press learn. And now RX has learned the noise profile. Over here to the right, we have threshold and reduction. Threshold sets the level between the main signal and the noise floor, and reduction is the amount of attenuation to the noise itself. So let's go over here and let's listen to the original file one more time. This recording has a really annoying air conditioning noise in the background. Let's see if we can somehow remove that. And now let's listen to the audio file with the default spectral denoise settings. This recording has a really annoying air conditioning noise in the background. Let's see if we can somehow remove that. Alright, so it's already much, much better. Now we can up this threshold and we can up the reduction as well. But of course we need to be careful because the more we up this, the more we also are going to intrude on the main signal. So this is sort of a balancing game between how much we can remove the noise until we start to sort of intrude into the main signal. But now that we've upped it a bit, let's try and preview it one more time. This recording has a really annoying air conditioning noise in the background. Let's see if we can somehow remove that. All right, that sounds pretty fantastic to me. Now, if there are too many artifacts in this method of doing it, we have something called artifact control. And this is basically gonna switch between spectral processing and wideband gating. So if you have a noise floor that is sort of pumping, you might want to change this over to musical noise. And if you have too many spectral artifacts, such as chirping, you might want to throw this back onto sort of mainly wideband gating. Again, this is sort of a balancing act. All right, let's close this down and let's open the voice denoise. Voice denoise is very similar in the way that, again, we can have RX learn the noise profile by itself, but also we can do it manually, and we're going to do that. So now the voice denoise module has learned the noise profile. And again, we have the same threshold and reduction settings over here. Let's try and listen to the audio file with the default voice denoise settings. This recording has a really annoying air conditioning noise in the background. Let's see if we can somehow remove that. All right, so I still hear quite a bit of the air conditioning unit at this point. So let's try and up the threshold, and let's try and up the attenuation of the noise itself. And let's see how this pans out. This recording has a really annoying air conditioning noise in the background. Let's see if we can somehow remove that. All right. And you might push this even further. Again, this is just sort of a balancing act. It's more important that you just understand how these things work. Let's try for the sake of this video to just up it a little bit more. And let's preview it with these settings. This recording has a really annoying air conditioning noise in the background. Let's see if we can somehow remove that. Let's listen to the original file. This recording has a really annoying air conditioning noise in the background. Let's see if we can somehow remove that. And let's listen to the denoise file. This recording has a really annoying air conditioning noise in the background. Let's see if we can somehow remove that. All right, that's a pretty huge improvement if you ask me. Yeah, and that's how denoising works in RX7. In this video, I want to touch on some of the different selection tools available to us in RX7 and how we can use those to make some really quick and efficient edits to our audio file. The selection tools are down here to the bottom right at this toolbar. And the leftmost selection tool is the time selection tool. And this allows us to make a selection in our audio file based on time. So let's say that we want to make an adjustment to anything in between 10 and 12 seconds. We can make a selection like so. I just want to quickly point out that you can make adjustments independently of each channel by clicking either at the bottom half of the right channel or at the top half of the left channel. And then you can make independent adjustments on each channel. We're going to conjoin the channels again by clicking anywhere sort of in the middle here. The selection tool next over is the time and frequency selection tool. Now let's say again that we want to make it a selection in between 10 and 12 seconds, but we only want to make an adjustment to frequency material between 1000 and 5000 hertz. We can make a square like so. And then we can only make an adjustment to this part of the frequency spectrum. The selection tool next over is the frequency selection tool, and this allows us to select bands of frequency across the entire duration of the audio file. So let's say that we want to make an adjustment to anything in between maybe 5 to 8K. We could come over here and watch this is the frequency spectrum on the right here. And let's make a selection between 5000 and 8000 hertz. There we go. Now we can make an adjustment only to this part of the audio file. Next over is the lasso selection tool, or the free draw tool, as I call it. This just allows us to make any shape or form that we want, like so, and we just have to end the loop, and it will create the shape for us, and we can move it around like so. Next over is the brush tool, and this will just allow us to brush over anything we want here. We can hold down our mouse and make the brush bigger or smaller like so. Next over is the magic wand tool, and RX will just try and automatically determine what it is that we want selected. So let's try and come down here to some of the deeper frequencies and hold that mouse here. So those are the selection tools we have available to us. And they're very important because we can make some really, really quick processes and edits with these tools via the instant process feature. If we check this box here, this drop-down menu will become available to us. And we have 5 different options here called attenuate, declick, fade, gain, and replace. And this allows us to make the chosen process instantly when we make a selection in the audio file. And this is really, really handy for a quick workflow. Let's turn off the instant process for a second. And let's listen to this audio file. This is a piano recording I did, and that has some obvious flaws in it that we're going to try and see if we can remove. Let's first hear it. All right, so there are some pretty glaring issues with this audio file as of right now. We have these clicks that sort of occur in the middle of the audio file, and then we have these beeps that sort of occur randomly throughout the file. And we're going to try and see if we can deal with those using this instant process feature right here. First of all, I'm just going to remove the waveform because it's not super helpful in this example. We have these 2 clicks that are quite visible here in the spectrogram. We're going to try to use the instant process declick feature. Now, I want to make sure that I have the time selection tool selected. Let's zoom in a little bit. And we can quite visibly see the 2 clicks here. Let's try and make a selection on both sides of this click, and let's see what happens. But first, let's just listen to this bit right here. Right, so a very apparent click right here. Let's click on instant process. We have declick selected. And then let's make a selection on either side of this click, and let's see what happens. There we go. Let's try and listen to this again. And just like that, the click has disappeared. Let's do the same over here. Let's just take a listen to this click. Yeah, so the click is right here. Let's turn on the instant process, declick, and let's make a selection again. And let's listen to this. And the click has disappeared. All right, fantastic. Let's zoom back out. And next, let's try and deal with these annoying little beep tones that occur sort of randomly throughout the clip. To do this, we're going to use the instant process replace feature. This will analyze the surrounding frequency material and try to determine what it is that we want removed and what it is that we want kept in the audio file. And to make these selections, we're going to use the time frequency selection tool, because by doing so, we can make a little box around these beeps that we want removed. Now, in case that we weren't necessarily sure where in the frequency spectrum these beeps were, now, of course, they're quite visible here, but they aren't always. We can make a selection and we can just hear that selection soloed, or the content within our selection. But it isn't so apparent, because let's say that we want to make a selection here and we want to listen to this. As you can hear, it's just playing the original audio file, and that's not what we want. We just want to hear the selected content here. To do so, we have to come down here, and next to the play button, there is a play button within this sort of square thing. Now, if you click this, then we're only going to hear our frequency selection. All right, let's bring it back to this play button here. Now we have our time and frequency selection tool. Let's zoom in a little bit. And let's also zoom in on the spectrogram a little bit. Now we can move around our audio file up here by selecting this box at the top of the window. Let's move it to the beginning of the audio file. And so quite visibly, the two first beeps are right here and right here. Let's click on instant process and replace. And let's make a square around these beeps. Let's see what happens. Let's make one around this. Let's move over on the audio file. And there's two here. Let's do the same. Let's move over. And I think this is the last one. Cool. Let's zoom out. And now let's listen to this. All right, so much better. Now, of course, there are going to be some artifacts by using this replace feature, because these beeps and the piano sort of occupy some of the same frequencies. But I think this is a fantastic result so far. Now, let's say that we want this piano piece to fade in a little bit more. Luckily, we also have the fade instant process. Now I have the time selection tool selected, and let's say we want to fade until about 3.5 seconds. Let's listen to that. All right, much better. Now let's make a fade at the end as well. As you can hear, it ends kind of abruptly. Yeah, that's kind of jarring. So let's make a fade at the end here as well. Now, if we try and do that like so, it's gonna make it fade in again, and obviously this is not what we want. What we have to do is come over to the utilities here and select the fade utility. And then select fade out instead. Now we also have different fades that we can choose from. We have logarithmic, linear, cosine, and equal power. We're gonna go with logarithmic for now, but we just have to select fade out here and then close down. Now let's make the selection again. Much better. All right, lastly, let's use the attenuate feature real quick. And this is just for example. This is not something I would do on this audio clip necessarily, but let's say that the high frequency material on this specific chord was just a little bit too harsh or whatever. We could select this part of the frequency spectrum and then just attenuate this part. Let's try and do that. So you can see that visibly that now the high frequencies of this chord have been attenuated. Let's try and give it a listen. This is not necessarily going to sound good, but you'll definitely hear sort of the change. Yeah, so that doesn't sound good necessarily, but you'll definitely see what this tool could be used for. All right, so these were some of the things you could do with the different kinds of selection tools and using the instant process feature to speed up your workflow. All right, so here we have a recording with a 60 hertz hum in the background. So let's see if we can remove that while leaving the dialogue mostly alone. All right, let's give this a listen. Here is a recording with a 60 hertz hum in the background. Let's see if we can filter that out. All right, so a very noticeable hum going on here. Let's see if we can remove that by using the de-hum module. All right. The first setting we want to select is the bass frequency, and we have three options. We have 50, 60 hertz, and free. Now, this depends on where in the world you live, what current your mains hum is. Now, I know for a fact that this is 60 hertz, but you could choose free if the mains hum is not exactly 50 or 60. You can freely choose the fundamental frequency. I know for a fact it's 60 hertz, so I'm going to select that. We have a high pass filter and a low pass filter available to us as well, but we're not going to use that for this example. We can choose the amount of attenuation by grabbing this little circle thingy, and we can choose the Q value by sliding using this little slider thingy. Now, of course, this is going to impact our main signal drastically, so let's revert back to 1000 for now. Below, we can choose the number of harmonics we're also going to notch out on top of the fundamental frequency, and we can choose the slope value because the upper frequencies are not usually as strong as the fundamental frequency or the first harmonic, so we can slope them out like this to not impact the main signal more than we have to. I'm going to leave it somewhere here for this example. All right, let's listen back to the original file once again. Here is a recording with a 60 hertz hum in the background. Let's see if we can filter that out. All right, let's listen back with the de-hum settings that we have. Here is a recording with a 60 hertz hum in the background. Let's see if we can filter that out. All right, that's a noticeable improvement. We have some humming still going on in some of the upper frequencies, but this is where I would start chaining together some modules. So for this example, I want to render out this de-hum effect to the audio file itself. So let's do that. And now that that's done, I'm going to close down the de-hum window. Now to remove the last part of the humming, I'm going to open up a module that we've already used in the video prior, the voice denoise module. And I have a feeling that this part is only going to be that distracting humming noise. Let's give it a listen. Yeah, so it's basically just noise. So we can use this to create a noise profile. Let's learn it over here. And now we've learned the noise profile in the voice denoise module. Now let's listen back to the entire audio file with these settings in the voice denoise module. Here is a recording with a 60 hertz hum in the background. Let's see if we can filter that out. All right. So I would say that that is a noticeable improvement from where we began. So this is an example of how you can chain together modules and also how to use the de-hum module. And chaining together modules, of course, is going to be very necessary for dealing with more complex audio repair situations. So this is one way of many that you could have done this, but there you go. In this segment, I want to process a voiceover, just like the one you're listening to right now. So first of all, let's have a listen to this audio file. For this voiceover, let's use 3 new modules. Let's use the DS module to try and combat those harsh S sounds. And let's use the deep breath module to attenuate those breaths that are just too loud. And lastly, let's use the mouth declick to try and get rid of those annoying little lip smack sounds. All right, perfect. So let's do just that. Let's start by coming over here and grabbing the DS module. We can choose between the classic algorithm or spectral processing. We're going to stick with the classic algorithm for now. And then we have the threshold level, and the cutoff frequency of which the sibilance must be above to be attenuated. Now I'm just going to listen back to this audio file with the default DS settings, and I'm just going to tweak these settings as we go along until I find a place that I'm happy about. So let's do that. For this voiceover, let's use 3 new modules. Let's use the DS module to try and combat those harsh S sounds. And let's use the deep breath module to attenuate those breaths that are just too loud. And lastly, let's use the mouth declick to try and get rid of those annoying little lip smack sounds. Alright, so I'm just keeping my eye on the amount of attenuation going on over here. I don't want it to be too much. I don't want any pumping in the audio. And we also have this cool feature there where if we take this box, we can output the S's only, so we can listen to the material that we are attenuating. And this can be really helpful when deciding where to set your cutoff frequency. So let's try and preview it with this setting turned on. Let's use 3 modules. Let's use the DS to try those harsh S sounds. Let's use the D to attenuate those just to. Let's use the to try. Alright, let's uncheck it and let's just preview this again. For this voiceover, let's use 3 new modules. Let's use the DS module to try and combat those harsh S sounds. And let's use the deep breath module to... Alright, cool. So in the interest of time, let's say that I'm happy with this result. I'm gonna go ahead and render this to the audio file. Cool. And when that's done, I'm just gonna close down the DS module. Now I'm gonna come over and select the breath control module. And this module is pretty straightforward. We have a sensitivity, and then we have the target level we want our breaths to be at. We can change this to the amount of gain reduction. But let's stick with target level for now. Sensitivity adjusts how many breaths are detected by the breath control module. Now, usually I just select a portion of the audio signal where I know there is a breath. So there's a breath right here. So I'm just gonna select on either side of this. And let's just try and listen to this. S sounds. And let's use the, right? So a breath right here. Now let's try and preview this with the default breath control settings. At those harsh S sounds. And let's use, so you'll notice that there's no attenuation right now, and that's just because the breath is already below the target level. So if we drop this down to, let's say, minus 42.5, let's try and preview it now, and there should be some attenuation now. At those harsh S sounds. And let's use the, and we can see the amount of attenuation going on right here. Let's drop this even further. At those harsh S sounds. And let's use the deep breath. All right, that sounds pretty good to me. Now, this module also has a output breaths only that we can check. And this is really handy because a lot of the times with the default settings, I found that the sensitivity is just too high. It's gonna start attenuating some parts of the audio that are not actual breaths. So let's preview this audio file with the output breaths only, and let's just adjust the sensitivity slider accordingly. So there's a breath here. Right, so there's some stuff over here that's definitely not breaths. So I'm gonna go ahead and I'm gonna lower the sensitivity even more. Let's try maybe over here. Let's make sure we have both channels selected. And let's just make sure that it's still capturing, it's still detecting this breath, but not the other parts of the audio that are not breaths. Let's try and uncheck the output breaths only, and let's listen to this part. Module to attenuate those breaths that are just too loud. And lastly, let's use the mouth declick to try and get rid of those annoying little lip smack sounds. Alright, so I don't necessarily hear any artifacts. Now this target level might be too low. You have to be sort of careful with this because with voiceovers especially, you can very quickly end up in this sort of uncanny valley of audio where people will listen to your audio and they'll feel like something is off. They can't just really put their finger on it. That might be because there's the level of the breaths are just too low because human beings, we breathe, right? So you have to be sort of careful with not removing all of the breaths. That might be counterproductive to what you're doing. So I think level maybe around 41.5 is good. Again, let's say that we're happy with this result. I'm going to render this out to the audio file. There we go. And lastly, let's open the mouth declick module. Now here again, we have the sensitivity that does exactly the same as the breath control. It detects how many of the mouth declicks there are. We can skew the frequencies for it to detect mainly higher frequencies or mainly lower frequencies. And we can widen the area that is going to be repaired around the mouth clicks itself. This might come in handy if you have some mouth clicks that are particularly hard to handle by the mouth declick. You might try and widen the clicks over here. I found that the default settings are actually usually pretty good. So let's just try and listen to this with the default mouth declick settings. For this voiceover, let's use 3 new modules. Let's use the DS module to try and combat those harsh S sounds. And let's use the deep breath module to attenuate those breaths that are just too loud. And lastly, let's use the mouth declick to try and get rid of those annoying little lip smack sounds. Cool. So we can keep track of how many clicks are repaired right here. Now, I know for a fact there is sort of a mouth declick at the end right here. Let's try and listen to that. Lip smack sounds. Let's see if we can repair this even further than it is right now. Let's just preview it with these settings again. Annoying little lip smack sounds. Right. I'm going to try and widen the click here a little bit. Let's just say 1.7. Annoying little lip smack sounds. All right. So that's already better. Now again, this module has a output clicks only feature that we can click on and we can listen just to the clicks. If we want to get a sense of what it is that we're taking out of the audio file, what it is that mouth declick is removing for us, we can do that. Let's try that. Right, okay, so it's basically just these unwanted clicks that can become a real nuisance and are just really annoying in any sort of voiceover. So this is a fantastic module that just automatically does this for us. Now again, let's say that we're happy with this result. Let's render this to the audio file. Right, and now we've gone through the DS, breath control, and the mouth declick. And we've rendered this to the audio file itself. Let's have a listen to the whole audio file now. For this voiceover, let's use 3 new modules. Let's use the DS module to try and combat those harsh S sounds. And let's use the deep breath module to attenuate those breaths that are just too loud. And lastly, let's use the mouth declick to try and get rid of those annoying little lip smack sounds. Cool. Let's try and undo all of the things we've just done, and let's listen to that. There we go. For this voiceover, let's use 3 new modules. Let's use the DS module to try and combat those harsh S sounds. And let's use the deep breath module to attenuate those breaths that are just too loud. And lastly, let's use the mouth declick to try and get rid of those annoying little lip smack sounds. Right, so a noticeable difference. Let's redo this. And listen to it again. For this voiceover, let's use 3 new modules. Let's use the DS module to try and combat those harsh S sounds. And let's use the deep breath module to attenuate those breaths that are just too loud. And lastly, let's use the mouth declick to try and get rid of those annoying little lip smack sounds. All right, that's fantastic. So at this point, I would take this audio file and export it and import it into my DAW of choice, and I would do my EQ and I would do my dynamic settings, and I would end up with this super clean and nice sounding voiceover. Now we've done these modules one at a time, but I want to pull your focus to this button up here called the module chain. And this allows us to chain together modules. Much like we did right now, you'll see that right now there is a DS module. We can add a module here and we can select the mouth declick that we just used. And we can also select the breath control that we just used. It's right here, it's at the top. And the cool thing about this is that now that we've selected all of these 3 ones, we can click here and we can do the settings so that it will fit my voice or whatever material you're working on. We can come up here and we can select add preset. And we can call this Anders Holm voiceover preset. And now every time I open up a voiceover that I've done, I can come up here and I can just select the Anders Holm voiceover preset from the list. I can adjust the settings and I can just render this straight to the audio file. And that really, really speeds up the workflow. So that is a super, super handy thing to have. And you can do presets for all sorts of things and all kinds of module changes that you can imagine. So yep, that's how you do that. Thank you for watching my portfolio video on RX7 Standard. Feel free to visit my website where you can find my resume, my other portfolios in Reels, and my contact information. Have a great day.